Okay, so we spent a lot of time graphing these linear functions on graph paper and trying to find the point of intersection. We're trying to find the point where this purple line, which has a positive 3 slope, looks like that, and the green line, which has a positive 5 slope, which is even steeper, like that. And so we're going to find the point of intersection without graph paper now, because I've already explained how to solve equations with the letter x on both sides. What? What do you mean? Well, this is called substitution. I got this y equals 5x plus 2. You guys can see that it is a straight line. Slope, y-intercept, slope. Here we got y-intercept, slope. If you put it on graph paper, you would find the point where they cross. But I'm going to show you guys some algebra where y equals this guy right here, but y also equals this guy right here. And so when I tell the kids it's called substitution, I basically say Mr. Gomes is the teacher and 5x plus 2 is the substitute teacher. That's the teacher that covers my class. The next day, I'm still sick. I can't be here, but they send another teacher. So the 5x plus 2 is a substitute teacher, and the 3x minus 8 is a different substitute teacher. But they're equal to each other. So you can literally write this math problem like this. 5x plus 2 equals 3x minus 8. Because these are both two different substitute teachers, which you should treat equally the same. Now, I've already taught you guys how to solve this math problem. We're going to solve for x. We're going to wind up with a number for x. As on a previous video, I showed you how to solve equations with letters, the letter x on both sides. And it went like this. The letter x is a variable, and we want to move it to the left. The number 2 is a number, and we want to move it to the right. And so what I showed you is if we subtract 3x on both sides, and I'm going to do it here in green, 3x minus 3x, I don't know what x is, but I'm just subtracting something from itself. So it actually goes away. But when we balance equations, I called it a teeter-totter. If we're going to minus 3x on the right, we need a minus 3x on the left. See how I have minus 3x on both sides? Whatever we did on both sides, it doesn't tip over the scale. It's still balanced. And 5x minus 3x, if you remember, is actually 2x. Now that positive 2 is a number, and negative 8 is a different number, but I don't want numbers on the left, I want numbers on the right. So I'm going to subtract 2 on the left and subtract 2 on the right, which now this guy goes away. And we have negative 8 minus 8, same thing, and negative 2 minus 2, same thing. And here we got a negative plus a negative, which gives us negative 10. Which now we have 2 times what number equals negative 10. And we can divide to get rid of multiplication, which is something I taught you on the previous video. And now you get just 1x is equal to negative 10 divided by 2, which is negative 5. And if you were to graph this guy, you would wind up seeing negative 5 for your x value. Now, we want to solve for y. Now, solving for y, we are going to want to take this negative 5, and if you remember our input-output, we can plug it in here, or we can plug it in here. And so I'm going to pick the easier of the two math problems, and I don't know about you. To me, they're both easy, but let's just put it up here with the 5. Y is equal to this green 5 times this negative 5, and I want to add 2 to that. And that's going to give me the number that goes there, which is the point of intersection. 5 times negative 5 is negative 25, plus 2, which will give you negative 23. And, oops, negative 23. And that's the point of intersection, okay? I hope you guys understood this video. When you have y equals on both of them, you just set them side by side. So take a look at the next video. It's going to be a little different. Thanks for watching.